Alright, so remember on video 2, we ended right on this page. The reason I stayed on here, because we're going to use these same charges over to keep our math at a minimum. So remember these two at 4 centimeters apart, that's a 225 attractive, not left or right, it's attractive force. And then these two red ones at 2.5 centimeters, we already found the force between those two to be 360. That's what you got to memorize and put it in the brain there. 360 attractive for these two red ones, 225 for there. All right, here we go. Next page. All righty, guys, we're going two-dimensional here. So we got your 5 and your 5, and we got this still at 4 centimeters, so everything's still the same. Okay, so we know that's a 360 repulsive on each other. That pulls 360 that way, that pushes 360 that way, not pull, it pushes. Whatever, it's a P. And then on the 8, so we're looking at net force in the upper left charge. Okay, so that pushes 360 straight up. Oh, and then this orange one, I didn't see it pop into there. That orange one pulls to the right at 225. It's attractive to this one. Guys, it's this vector addition. We're going to add the orange plus the purple. Boop, there's your answer. That's how you do your vectors in 2 dimensions. Okay, it's not all that difficult. So you got your 225 straight up. That's the purple one. You got your 3. Oops, nope, I got that backwards. I wasn't even paying attention. 225 is to the right. That's the orange one. The 360 is the straight up. So do your Pythagorean theorem. That's a 425 for that blue one right there, guys. So that means the net force on the upper left charge is in this way. 425. Now let's do some math. Okay, so if you're doing this angle right over here, that would be the opposite side, the Y, the purple, which remember we said was the 360, over the adjacent, which is the 225, and then you do the inverse tangent of that. That's 58 degrees positive, or from here, that's 58 degrees from your positive x-axis. Yeah, that's supposed to be degrees. It's something Greek. It all works. It's an angle. So there it is, guys. 425, 58 degrees. If you want to think about north of the east, that's fine. But if we're using just your polar coordinates, that's 0, 90, 180, 270, and back to 360 or 0. That's 58 degrees. Oh, there you go. Hey, honors only. Oh, I don't know if you guys are honors people, are you? You're an AP. So what that means is to find the net force on the lower left-hand charge. Now we're doing this one. Part of our work's done because we did that one already, right? We already did that. We already know that's a 360 downward. But what we didn't do is this one, because it's not 4 centimeters anymore. So now we've got to do some extra work. All right, ready, honors kids? So remember, there's an attractive force this way. More or less than 225? It's less because it's further away, right? All righty, so let's go ahead and do all that math stuff and we'll be done with it. So we already did that and that, but it's a different distance on the bottom. So we're doing the Pythagorean theorem of the 4 squared and the 2.5 squared, but only in terms of meters. And then you do the square root of that. But remember, we've got to square it, so that's why that disappears, and that's why you have that. So it's 162. So it is an attractive 162 instead of 225. It's 162 is further apart. And then you do your angly thing on there, and you find out if you want to find the angle. It's 85.75. Oops, I'm sorry, it's 32 degrees. So it's 32 degrees from here, or 58 degrees right there if you're doing the tangent of this side over that side. Okay, it looks like they did the opposite. They did this tangent of this side over that side. That's why they found that to be 32. Perfect. Alrighty, guys. Well, now here's the problem. SOHCAHTOA only works at right angles, so now you got to convert this orange thing into your X and your Y components right here. Your X and your Y components. And that's what's going on over here. Oh, I'm sorry, over here. So now that we know our angle is 32, We do a little cosine thing to find the adjacent side, which is the x value of that one, which is 137.2. Then we find the y version, this little one right over here. That's the sine because that's the opposite, and that's 85.75. So the reason we have an x and a y component now, well, now what we can do is we can add your x's and your y's together. So keep in mind, we don't have other x's than the 137 there. So that's why the 137 is the only x. But for the y's, remember, we got a 360 downward, but we have an 85 up. So you minus the 85 from the 360 there. It's a square. It doesn't matter if it's positive or negative. And you end up with a 307. So the net force on this one is a 307. Then you got to do your tangent stuff over here to find your angle. And you find it to be an angle of when you're all done, the final angle of this thing over here, not this one, is 63 negative. Whoops, I'm sorry, it's the blue one. So we're adding the orange plus the purple. My bad, orange plus the purple. And so when we added our x's together, which is only one x, and we added our y's together and they're opposite of each other, we did this line. That's what we found, guys, is this line. Here's your x's, which is the 137 this way, but it is the difference between those two on the way down. That's straight over here. And that's the difference between those two. So now doing your inverse tangent thing of that, it's negative 63, meaning it's below the x by 63 degrees. So that's more fun with your two-dimensional stuff there, guys. All right, hope that was fun. What if it was 3D? You'd have to do one more of these things for the one coming in out of the page. This stuff's coming out of the page or into the page, but yeah, we don't have to do that. All righty. So electric field strength. We're actually going to stop right there because that's a whole different topic all by itself. All righty. So that's the end of video number 3.